The human perception of time is a fragile thing, measured in the fleeting pulse of a heartbeat or the swift rotation of a planet that has only recently known the presence of our kind. We exist in a thin sliver of light, a momentary spark in the vast cold history of a world that was old long before our ancestors first looked toward the stars. To truly understand the Cambrian, one must first surrender the comfort of the familiar and descend through the layers of the geological record, past the bones of empires and the dust of mountains, into a depth of 540 million years. Here, the clock slows until every second is 1,000 years, and every breath is an epoch. We are traveling to a time when the Earth was a stranger to itself, a silent, drowning sphere of turquoise and charcoal where the sun did little more than graze the surface of a global ocean. Beneath that surface, the atmosphere of the deep is defined by a crushing, indifferent gravity. The water of the Cambrian is thick, heavy, with the minerals of a world still cooling, a saline womb characterized by a higher viscosity than the oceans we swim in today. There is a profound weight here, the hydrostatic pressure pressing against the rudimentary membranes of life with a force that is both a prison and a cradle. The chemistry of this water is a volatile soup of dissolved carbonates and sulfurous vents. A chaotic environment where oxygen is only just beginning to saturate the dark. You can feel the tectonic vibrations humming through the crust, the slow grinding movement of the great supercontinent Gondwana as it shifts its massive weight across the southern hemisphere. The soundscape is not one of silence, but of a low-frequency thrum, the rhythmic pulse of the tides moving much faster than they do now, driven by a moon that sits closer to the Earth, pulling at the sea with a terrifying magnetic intimacy. In this eternal twilight, the first great experiment of complex anatomy is unfolding. The seafloor is a vast, undulating carpet of microbial mats, a velvet-like expanse of cyanobacteria that has held dominion for billions of years, but now it is being torn asunder. Emerging from the silt is the first true nightmare of the abyss, the predatory worm, a creature of pure muscle and intent. Its body is a masterpiece of hydrostatic engineering, a series of pressurized chambers that allow it to tunnel through the anoxic mud with a rhythmic, pulsing motion. It possesses no bones, yet its skin is toughened by the first secretions of collagen, a biological armor designed to withstand the abrasive grit of the volcanic sand. The nervous system of such a creature is a simple, elegant braid of fibers, yet it represents the first time the universe has developed the capacity to feel the vibration of a passing shadow. This is the dawn of the sensory era, a moment where the world stops being a passive collection of chemicals and becomes a theater of observation. In the darkness, the first primitive photoreceptors are beginning to distinguish the gradient of the light above from the blackness of the mud below. It is a haunting thought to realize that the very mechanics of your own sight, the intricate dance of light hitting your retina, had its origin in these suffocating, lightless depths. We are looking back at the foundation of our own suffering and our own wonder. The weight of this eternal dark is not just the weight of the water, but the weight of our own ancestry, pressing down through the strata of time. The shift from the tranquil, stagnant oceans of the Ediacaran to the high-energy volatility of the Cambrian was not a subtle transition, but a geochemical upheaval of staggering proportions. As the supercontinent of Rodinia continued its slow tectonic disintegration, the shallow seas expanded, spilling over the continental shelves and creating vast, sun-drenched nurseries of liquid emerald. But it was the hidden chemistry of the water that dictated the pace of the nightmare. The Earth's crust was exhaling, releasing massive quantities of calcium and phosphate through hydrothermal venting and the weathering of fresh volcanic rock. This sudden surge in mineral availability acted as a biological catalyst, providing the raw materials for a revolution in architecture. Life, which had been soft and ephemeral for eons, began to drink the stone, sequestering these minerals to build the very first fortifications of the body. The atmosphere of this era was a heavy, humid shroud, but beneath the waves the concentration of dissolved oxygen was beginning to pulse in rhythmic, life-giving waves. We called this the oxygen pulse, a series of spikes in atmospheric concentration that breached a critical threshold, allowing for the metabolic expense of movement. Oxygen is a volatile fuel, and its sudden abundance turned the slow, drifting organisms of the deep into high-performance biological machines. The viscosity of the water, once a barrier to speed, was now a medium to be conquered by the rhythmic contraction of complex muscle tissues. The seafloor, once a static graveyard of microbial mats, was being churned by the first burrowers, a process known as the Cambrian substrate revolution. This bioturbation released nutrients that had been locked in the sediment for 1 billion years, fueling a feedback loop of growth and aggression that the planet had never before witnessed. Consider the anatomical miracle of the first mineralized skeletons, the small shelly fauna. These were not the grand predators of the later Cambrian, but tiny, microscopic shards of armor, tubes, scales, and translucent cones that represent the first time life learned to hide behind a wall of crystal. To a creature living in this era, the development of a shell was an evolutionary epiphany, a response to a world that had suddenly become hungry. The nervous systems of these organisms were beginning to centralize, forming the first rudimentary brains capable of processing the chemical signatures of fear. The water was no longer just a habitat. It was a sensory field of chemical plumes, vibrations, and the faint ghostly signatures of nearby life. This was the invention of the other, the realization that there were things in the dark that could be consumed and things that could consume you. This geochemical awakening forces us to reflect on the cold mechanical nature of our own existence. We are, at our core, a collection of minerals and gases that have been organized by the relentless pressure of time and the availability of oxygen. The pulse that gave rise to the Cambrian monsters is the same pulse that sustains the delicate firing of your own neurons as you drift towards sleep. The nightmare was not born of malice, but of a sudden, overwhelming abundance of energy, a fire that has been burning for 500 million years. As the minerals settled and the shells hardened, the stage was set for the arrival of the great architects of the abyss, creatures that would define the very nature of power in a world of water and stone. In the velvet darkness of the Cambrian Sea, the greatest revolution in the history of life was not one of teeth or claws, but of light. For nearly 3 billion years, the inhabitants of Earth had drifted in a sensory void, navigating by the slow chemical whispers of the current or the tactile brush of the silt. But as the sun's rays penetrated the increasingly clear water, a new biological apparatus began to coalesce from the proteins of the deep, the eye. This was the moment the abyss gained a witness. The invention of vision transformed the ocean from a world of touch into a theater of geometry and distance, where a predator could track its prey from across the gloom. The first eyes were not the soft, liquid globes of mammals, but rigid crystalline structures carved from the same calcite that formed the shells of the era's inhabitants. The most sophisticated of these early observers were the trilobites, creatures whose very existence was defined by their extraordinary visual arrays. Unlike any organism that follows them in the fossil record, trilobites possessed lenses made of pure, optical-grade calcite translucent crystals that did not soften or decay. These were compound eyes composed of hundreds of tiny hexagonal prisms, each one a precision-engineered telescope directed at a different fragment of the horizon. In some species, these eyes were mounted on tall periscopic stalks, allowing the creature to remain buried in the cool, anoxic mud while scanning the water column for the distorted silhouette of a hunter. The physics of these lenses was impeccable. They were often bifocal, corrected for spherical aberration by a subtle internal layer of magnesium, a feat of optical engineering that humanity would not replicate until the 17th century. To imagine the world through a trilobite's gaze is to envision a fragmented, panoramic mosaic of movement and shadow. The water would have appeared as a shifting grid of light and dark, where the slightest flicker of a fin or the undulation of a soft-bodied worm was amplified into a signal of immediate survival. This was the birth of the visual field, a concept that forced every other living thing to adapt or perish. The pressure to remain hidden gave rise to the first camouflage, the first defensive burrowing, and the first frantic bursts of speed. The nervous system, once a simple relay for chemical signals, was now forced to expand, developing the complex processing centers required to interpret the deluge of data streaming in from the calcite lenses. The brain was being forged in the furnace of optical complexity, driven by the need to map the three-dimensional reality of the hunt. As we contemplate these ancient, stony eyes, we are forced to confront the chilling indifference of the evolutionary process. These creatures saw a world that was utterly alien to us, yet the fundamental geometry of their vision laid the groundwork for our own perception of reality. The light that reached the bottom of the Cambrian Sea was the same light that enters your room tonight, yet it was filtered through a mind of crystal and chitin. The witness has changed, but the dark remains the same. We are merely the latest in a long line of observers, staring out from our own brief moment of light into the same vast, unblinking silence that the trilobites navigated 500 million years ago. The eye was the first weapon of the nightmare, and once it was opened, the darkness would never be truly safe again. The transition from the architectural triumph of the eye to the visceral reality of the hunt marks the true beginning of the Cambrian nightmare. In the newfound clarity of the visual era, the seafloor became a landscape of terror, necessitating a shift from passive filtration to active, calculated destruction. The atmosphere of the deep was no longer merely a pressurized sanctuary, it was a medium for the transmission of fear. Predation demanded a new kind of biological machinery, a convergence of speed, grip, and the mechanical power to breach the mineralized defenses of the era's armored inhabitants. The water column was soon dominated by the radiodonts, a group of apex hunters whose very name, meaning radiating teeth, whispers of the circular, jagged horrors they brought to the primordial dark. At the center of this evolutionary arms race was the mouth of Anomalocaris, a structure that defies modern comparison. It was a radial aperture, a ring of 32 overlapping plates that functioned like the iris of a camera but with the intent of a nutcracker. These plates were not teeth in the mammalian sense, but hardened cuticular structures, often serrated with razor-sharp protrusions designed to find the weak points in a trilobite's calcified carapace. The mechanics of this bite were terrifyingly efficient. As the ring contracted, it created a shearing force that could crush and grind through the toughest chitin. To a creature caught in this spiral of teeth, there was no escape, only the rhythmic mechanical pulverization of its body, as it was drawn into the dark gullet of the predator. Supporting this nightmare maw were two massive jointed appendages that extended from the head like skeletal sides. These limbs were equipped with inward-facing spines, allowing the predator to snatch prey from the water column or rake the sediment for hidden victims. The musculature required to operate these limbs was immense, fueled by a high metabolic engine that demanded constant consumption. The nervous system of the predator had to be equally sophisticated, possessing the spatial awareness to coordinate the movement of the limbs with the tracking of the compound eyes and the opening of the radial mouth. This was the birth of the tactical strike the moment life learned to use physics and geometry to extinguish the spark of another. As we dwell on the image of the serrated ring, we are reminded of the cold, cyclical nature of the universe. The Cambrian mouth was a machine for the recycling of carbon, a brutal necessity that drove the complexity of every nervous system and defensive shell that followed. The nightmare of the deep is not found in the darkness itself, but in the relentless ingenuity that life displays when it seeks to survive at the expense of another. We are the inheritors of this violence, our own survival built upon the ancestral foundations of the hunt. The silence of the deep time ocean is not the silence of peace, but the silence of a predator waiting for the slightest vibration in the dark, a reminder that the history of life is a long, slow digestion, punctuated by the snapping of shells and the indifference of the tides. In the vast, undulating silence of the mid-water column, the supreme architect of Cambrian terror drifted with a deceptive, ghostly grace. Anomalocaris canadensis, the abnormal shrimp of Canada, was a creature that shattered every biological precedent of its time, at a length of nearly a meter a size that made it a titan in a world of miniatures. It moved not through the sediment, but through the open void, a realm where there was no place to hide. The atmosphere surrounding this predator is one of fluid dynamics and calculated shadows. To understand its dominance, one must look to the rhythmic pulsing of the flexible flaps that lined its flanks. These were not the frantic legs of a crawler, but a series of overlapping lobes that moved in a metrical, wave-like motion, allowing the creature to fly through the high-viscosity brine with the silent efficiency of a modern ray. The anatomy of an Anomalocaris was a terrifying synthesis of sensory precision and mechanical power. Its head was dominated by two enormous bulbous compound eyes, each mounted on a thick, muscular stalk. Recent paleontological analyses from 2024 and 2025 suggest these eyes contained up to 16,000 hexagonal lenses, providing a visual resolution that far surpassed almost anything else in the Cambrian Sea. This was a hunter that did not merely stumble upon its prey, it stalked it with a predator's calculated geometry, tracking the frantic movements of trilobites from the sun-dappled surface down into the crushing dimness of the benthos. The creature's nervous system was a centralized command center, processing high-speed visual data to coordinate the strike of its two formidable frontal appendages. Great, jointed limbs armed with barbed spikes that could impale and draw prey toward that horrific circular maw. Beyond its physical prowess, the existence of Anomalocaris signifies a profound evolutionary milestone, the emergence of the trophic cascade. By occupying the position of apex predator, this creature exerted a top-down pressure that dictated the survival strategies of every other living thing. The thickening of shells, the development of defensive spines, and the evolution of complex burrowing behaviors were all, in part, a response to the shadow of the abnormal shrimp. Its presence meant that life could no longer afford to be complacent. It had to be fast, it had to be armored, or it had to be invisible. The biological mechanics of its digestion, its sophisticated circulatory system, and its massive energy requirements forced a massive acceleration in the complexity of the entire marine ecosystem, turning the ocean into a high-stakes arena of life and death. As we watch this ancient phantom glide through the mind's eye, we are struck by the cold, beautiful indifference of its design. Anomalocaris was the first to master the art of the kill on a grand scale, a sovereign of the deep time abyss that eventually vanished, leaving behind only the crushed shells of its victims and a few ghostly imprints in the shale. It reminds us that every rain, no matter how absolute, is eventually reclaimed by the silt. We are looking back at a king from a lost world, a reminder that the history of our planet is a succession of masters, each one perfect for its moment, and each one destined to be forgotten by the rising tides of the eons. The nightmare of the Cambrian was not a failure of nature, but its first great masterpiece of power. In the surreal gallery of the Cambrian, where the boundaries of biological possibility were being tested with reckless abandon, few forms evoke as much disorientation as Opabinia regalis. To witness this creature is to look upon a fever dream of evolution, a design so alien that when its first fossils were presented to the scientific community, the room erupted in laughter. It is a testament to the fact that in the deep time of the abyss, nature was not following a blueprint recognizable to the modern mind. The environment Opabinia inhabited was one of shifting silts and deceptive currents, a world where the pressure of the water column acted as a molding force on the plasticity of the flesh, measuring only a few inches in length. This soft-bodied enigma possessed a segmented trunk and a series of lateral swimming flaps, allowing it to hover just above the seabed like a spectral hovercraft. The true nightmare of Opabinia, however, lies in its sensory and predatory apparatus. Atop its head sat 5 stalked, compound eyes clustered like a crown of obsidian beads. This 5-fold gaze granted the creature a near-spherical field of vision, a 360-degree surveillance system that ensured no shadow could move in the brine without being detected. This was a redundant, overlapping visual array, likely capable of perceiving depth and motion, with a precision that turned the chaotic seabed into a structured map of opportunities. But it is what lay beneath these eyes that defies classification. A long, highly flexible proboscis, or nozzle, that extended forward like a vacuum hose. This organ was tipped with a set of grasping spines, a biological claw used to snatch small, soft-bodied prey from the crevices of the mud and drag them back to a mouth that opened backwards, situated beneath the head. The biological mechanics of the Opabinia proboscis represent a masterpiece of hydrostatic pressure. By shifting internal fluids, the creature could extend and retract this arm with startling speed, a hydraulic strike that was as silent as it was lethal. Its nervous system was tasked with the immense complexity of coordinating 5 independent visual inputs, while simultaneously navigating the articulated arm toward a target. Peer-reviewed studies from the last year suggest that Opabinia likely possessed a sophisticated cluster of ganglia, a precursor to a centralized brain dedicated almost entirely to the processing of this multidimensional sensory data. It was a specialist of the microhunt, a creature that occupied a niche of surgical precision in an ocean of brute force. As we linger on the image of this 5-eyed ghost, we are invited to reflect on the sheer otherness of deep time. Opabinia belongs to no living group of animals. It is a stem group arthropod, a lonely branch on the tree of life that grew for a time and then withered into the stone. It represents a lost direction, a biological thought that the universe had and then eventually discarded. To contemplate such a creature is to realize that our own form 2 eyes, 4 limbs, a forward-facing mouth, is not an inevitability, but merely one path among millions. We are the survivors of a long, cold winnowing process, standing on the shore of a history littered with the beautiful, failed experiments of the dark. In the soft, suffocating silts of the Burgess Shale, where the boundary between life and the inorganic mud was often a matter of mere chemistry, there existed a creature whose very name acknowledges its impossibility. Hallucigenia sparsa is a name born of the initial disbelief of its discoverers, a recognition that the anatomy before them felt less like a product of natural selection and more like a fever dream etched into stone. To enter the world of Hallucigenia is to descend into a realm of surrealist geometry, where the crushing weight of the deep ocean dictated a form that seems to defy the laws of terrestrial biology. It was a creature of the abyss, measuring no more than a few centimeters, yet it possessed a visual and structural presence that continues to haunt the halls of paleontology. The biological architecture of Hallucigenia is defined by a startling duality: a row of 7 pairs of rigid, needle-like spines on its back, and a corresponding row of 7 pairs of soft, fleshy tentacles on its underside. For decades, the scientific community struggled to even orient the animal, reconstructively placing it upside down, imagining it walking across the seafloor on its spines like a stilted marionette. However, peer-reviewed data from 2024 into 5 and 225 has solidified our understanding of its true mechanics. The tentacles, tipped with tiny bifid claws, were the primary means of locomotion, hydrostatic tubes that pulsed with the internal pressure of the creature's circulatory system. The spines, meanwhile, were a sophisticated defense against the predatory terrors of the mid-water, a carbonaceous picket fence designed to make the creature an impossible swallow for the likes of Anomalocaris. At one end of its elongated, tubular body sat a head that was, for millions of years, mistaken for a tail. Within this bulbous extremity lay a simple, yet terrifyingly efficient digestive system, leading to a mouth lined with rows of internal teeth, not for chewing, but for ensuring that whatever soft organic matter it vacuumed from the seafloor could not escape. Its nervous system was a delicate, uncentralized lattice, yet it was capable of coordinating the complex, rhythmic movement of its 14 legs. It lived in a state of constant, slow-motion vigilance, a tiny fortress of spikes and flesh navigating the dark. The iridescent sheen of its body, revealed by modern electron microscopy, suggests a level of structural coloration that would have shimmered in the faint, blue-shifted light of the Cambrian noon. A spectral ghost moving through the gloom, contemplating Hallucigenia forces a confrontation with the sheer plasticity of life. This creature, which seems so alien that it could have fallen from a distant star, is in fact a distant relative of the modern velvet worm, a thin but resilient thread in the tapestry of our planet's history. It is a reminder that the nightmare is often merely a matter of perspective. To the Hallucigenia, its spines were not a horror, but a sanctuary. Its tubular body not a deformity, but a masterpiece of deep-sea engineering. We look at it through the lens of 500 million years of evolution and see a monster, but in the silence of the Cambrian deep, it was simply a survivor, a small shimmering defiance against the cold, indifferent pressure of the eternal dark. In the vast open water expanses of the Cambrian Ocean, there drifted a titan of filtered light and geometric precision. Herdia Victoria represents a lineage of radiodonts that traded the raw, aggressive pursuit of Anomalocaris for a more enigmatic architectural dominance. To understand Herdia, one must first visualize the sheer scale of its cranial carapace, a massive, hollow structure that extended forward from its head, nearly half the length of its entire body. In the crushing silence of the deep, this carapace acted as a hydrodynamic stabilizer, a shield of chitinous plates that allowed the creature to glide through the brine with an eerie, unhurried stability. The environment surrounding Herdia was one of constant, vertical migration, a world where the creature hung suspended in the water column like a silent, floating cathedral of flesh and stone. The biological mechanics of Herdia were centered around a specialized, high-efficiency feeding apparatus. Unlike the spiked sides of its more famous relatives, Herdia possessed frontal appendages equipped with long, slender spines that formed a delicate rake-like sieve. Peer-reviewed research from 2025 has highlighted the fluid dynamics of this system, suggesting that Herdia was a macroscopic filter feeder, a prehistoric precursor to the baleen whales. As it drifted through the high-viscosity currents, it would sweep these appendages through the water, trapping thousands of tiny, soft-bodied organisms and suspended organic particles. Its mouth, the iconic radial patoia ring, was not merely a crushing tool, but a sophisticated processing plant capable of sorting the nutrient-rich slurry from the inorganic grit of the sea. The nervous system of such a creature was a marvel of sensory integration. To maintain its position in the currents, Herdia relied on a complex array of lateral lobes, pulsing flaps of tissue that moved in metronomic synchronization. This required a centralized neural cluster capable of monitoring the pressure of the water against its massive carapace while simultaneously coordinating the rhythmic filtering of its limbs. The eyes of Herdia, though less bulbous than those of the apex predators, were finely tuned to detect the faint, bioluminescent flickers and chemical plumes of the mid-water. It lived in a state of perpetual meditative consumption, a giant whose existence was a slow-motion dance with the tides, its body a testament to the fact that even in a world of nightmares, there is a place for the patient and the massive. Reflecting on the hollow carapace of Herdia Victoria brings us to the edge of a deep-time mystery. For decades, paleontologists found these strange triangular plates in isolation, unable to imagine the creature they belonged to. It serves as a haunting metaphor for the fragments of our own history, the realization that we see only a fraction of the truth. Herdia reminds us that the abyss is not just a place of violence, but a place of vast, quiet complexity, where life can take on forms that challenge your understanding of what is possible. As it drifted through the Cambrian noon, it carried with it the silence of the eons, a floating monolith that eventually sank into the mud, leaving behind a riddle in the stone that took 500 million years to solve. On the lightest plains of the seafloor, where the pressure of the ocean is felt as a constant, heavy embrace, life did not always seek speed or size. Some chose the path of the stationary fortress. Wiwaxia corrugata is the embodiment of this philosophy. A creature that exists as a shimmering armored mound of iridescent geometry. Measuring no more than 2 inches in length, Wiwaxia resembled a subterranean jewel, or a pine cone of carbonaceous silk. The environment it navigated was one of abrasive volcanic sands and the constant raining detritus of the upper layers. Here, the water is thick with the scent of sulfur and minerals, and the only movements are the slow rhythmic pulses of the tide and the creeping shadows of predators. The anatomy of Wiwaxia is a study in defensive sophistication. Its entire dorsal surface was covered in a complex mosaic of overlapping scales known as sclerites. These were not bone but a hardened organic material, possibly a precursor to the chitinous armor of modern insects. Each scale was etched with microscopic longitudinal ribs that acted as diffraction gratings. In the presence of even the faintest glimmer of light, Wiwaxia would have shimmered with a structural iridescence, a spectral play of colors that served as a visual warning in the gloom. Emerging from this scaled carapace were 2 rows of long serrated spines projecting upward like the pikes of a medieval phalanx. These spines were the ultimate deterrent, designed to pierce the soft mouthparts of any radiodont that attempted to overturn the creature. The biological mechanics of Wiwaxia were hidden beneath its armor. It possessed no visible legs. Instead, it moved on a soft, muscular foot, much like a modern slug or snail. This foot secretes a layer of mucus that allowed the creature to glide over the jagged topography of the seabed with a slow, meditative persistence. Beneath its head, it housed a sophisticated feeding apparatus, a radula-like structure equipped with 2 rows of teeth. Peer-reviewed studies from 2025 suggest these teeth were highly specialized for rasping microbial biofilms and algae from the rock, a task that required a surprising degree of muscular coordination. Its nervous system was a decentralized net, focused primarily on the tactile and chemical signatures of its immediate surroundings, allowing it to sense the approach of a predator long before the shadow fell across its scales. To contemplate Wiwaxia is to understand the power of patience in deep time. It did not hunt, nor did it flee. It simply endured, a small shimmering defiance against a world of jaws and claws. It reminds us that survival is often a matter of holding one's ground, of building a fortress within, and waiting for the era of violence to pass. In the cold, unblinking eye of the Cambrian Wiwaxia was a quiet success, a masterpiece of structural defense that eventually vanished into the shell, leaving behind only its scales as a reminder of a time when life was a slow-motion dance of armor and light. Amidst the gargantuan carapaces and the 5-eyed titans of the Cambrian abyss, there moved a creature so unassuming that it might easily have been overlooked in the theater of monsters. Pikaia gracilens was a delicate, ribbon-like sliver of flesh, barely 5 centimeters in length, swimming with a frantic lateral undulation. It possessed no armor, no serrated rings of teeth, and no crystalline lenses. Yet, in the terrifying context of deep time, Pikaia is the most significant ghost in the archive. It represents our own beginning, the fragile thread of the chordate lineage that would one day lead to the rise of the vertebrates. The environment it navigated was a treacherous obstacle course of predatory shadows and suffocating silts, where its only defense was a rudimentary agility and the transparency of its own body. The biological architecture of Pikaia was a radical departure from the rigid externalized engineering of the arthropods. Running along the length of its dorsal side was a flexible, stiffening rod of tissue known as the notochord. This was the precursor to the human spine, a structural innovation that allowed for the attachment of zigzagging blocks of muscle called myomeres. By contracting these muscles in sequence, Pikaia could whip its body into a rhythmic S shape, propelling itself through the high-viscosity brine with a speed that many of its armored contemporaries could not match. Peer-reviewed data from 2025 has confirmed the presence of a primitive vascular system and a series of gill slits near its head, allowing it to extract oxygen from the mineral-rich water with increasing efficiency as the Cambrian oxygen pulse intensified. The nervous system of Pikaia was a masterpiece of potential. It lacked a true brain, possessing instead a slight swelling at the anterior end of its hollow nerve cord. This was a centralized processing unit in its infancy, receiving input from two tiny sensory tentacles that probed the water for chemical signatures and vibrations. While the trilobite relied on the permanence of stone-like eyes, Pikaia relied on the plasticity of soft tissue and the integration of movement. It was a creature of the inside out, where others built walls of calcium to keep the world away. Pikaia built a sophisticated internal scaffold to navigate the world more deeply. This internal focus allowed for a level of metabolic flexibility that would eventually outlast the rigid giants of the Burgess Shale. To look upon the fossil of Pikaia is to experience a profound sense of vertigo. This tiny, vulnerable, eel-like creature carried within it the blueprint for every bird, every whale, and every human who would ever walk the earth. It lived in the shadow of the nightmare, a flickering spark of life in an ocean of crushing indifference. It reminds us that our ancestry is not one of ancient strength, but of ancient persistence, a testament to the fact that survival does not always belong to the most heavily armored, but to those who can adapt within the hollows of the dark. As Pikaia swam through the Cambrian twilight, it was a silent promise of a future yet to be written, a thin line of nerve and muscle that refused to be extinguished by the weight of the eternal dark. The transition from the soft rhythmic pulsations of the early Cambrian into a world of structured violence was heralded by a singular mechanical breakthrough, the invention of the jaw. Before this moment, the act of consumption was a passive or clumsy affair, a matter of vacuuming detritus or crushing soft tissue with external plates. But as the competition for survival intensified beneath the weight of the global ocean, life began to reconfigure the very arches of its throat. The jaw was not merely a tool for eating. It was a revolutionary weapon of precision engineering that redefined the physics of the hunt. It allowed for a concentrated application of force, a localized pressure capable of snapping the mineralized defenses that had previously rendered many organisms invulnerable. The biological mechanics of the first jaws were a masterclass in repurposed anatomy. Peer-reviewed data from 2025 and 2026 suggest that these structures evolved from the anterior gill arches, the cartilaginous or bony supports that once held the respiratory system open. In a spectacular display of evolutionary plasticity, these arches migrated forward, becoming hinged and articulated. This provided a mechanical advantage that allowed for the gape and suck feeding method, where a sudden expansion of the oral cavity creates a localized vacuum, drawing prey into the maw before the hinges snap shut with terminal force. The nervous system had to undergo a simultaneous expansion to manage this. The development of complex cranial nerves was required to coordinate the intricate dance of muscle and bone, turning the head into a sophisticated terminal for predation. This innovation triggered a massive shift in the environment's sensory landscape. With the arrival of the jaw, the bite became the defining interaction of the deep. It forced an immediate response from the armored inhabitants of the seafloor, who began to develop even more complex sclerites and spines to survive the new targeted lethality of their hunters. The water chemistry itself was impacted by this transition, as the increased efficiency of predation accelerated the cycling of nutrients through the water column. The sea was no longer a place of drifting shadows. It was a high-velocity arena where the speed of a reflex and the strength of a hinge determined which lineages would continue and which would vanish into the anoxic mud. Contemplating the invention of the jaw brings us face to face with the cold, functional beauty of our own anatomy. The very bones that allow you to speak, to breathe, and to eat are the descendants of those ancient, repurposed gill arches that first snapped shut in the Cambrian gloom. We are built upon a foundation of predatory necessity. Our bodies a living map of the ancient struggles for energy and survival. The silence of the deep time ocean was broken by the first mechanical click of bone on shell, a sound that signals the end of the primordial peace and the beginning of a world where life must consume life to persist. It is a reminder that even our most basic functions are echoes of a nightmare that was solved by the relentless ingenuity of the dark. In the profound stillness of the Cambrian abyss, where the weight of the water acts as a relentless sculptor of form, the rise of the arthropods was predicated on a singular molecular miracle, the synthesis of chitin. This complex carbohydrate, a long-chain polymer of N-acetylglucosamine, became the foundational fabric of the nightmare. It is a material of paradoxical properties, lightweight enough to allow for agile movement, yet structurally resilient enough to withstand the crushing hydrostatic pressures of the deep. To understand the Cambrian is to understand the chemistry of this biological armor, a substance that allowed life to transition from the soft, vulnerable pulses of the Ediacaran into the rigid, articulated precision of the first great hunters. The biological engineering of a chitinous exoskeleton is a masterpiece of layered defense. Within the tegument of a trilobite or a radiodont, chitin fibers are arranged in a helicoidal or bouligand structure, a series of stacked layers where each successive sheet is slightly rotated relative to the one beneath it. This geometry creates a material that is exceptionally resistant to crack propagation. Even if the serrated ring of a predator strikes the shell, the energy of the blow is dissipated through the rotating layers rather than shattering the core. Peer-reviewed studies from 2025 have further revealed that many Cambrian organisms infuse this chitinous matrix with calcium carbonate or magnesium, creating a biocomposite that rivaled modern ceramics in its hardness. This was the invention of the hard shell lifestyle, a chemical commitment to permanence in a world of fluid chaos. However, the chemistry of chitin imposed a brutal tax on its owners, the necessity of the molt. Because a rigid shell cannot grow, the inhabitant is trapped within a fortress that eventually becomes a tomb. The process of ecdysis, the shedding of the old skin, was perhaps the most vulnerable moment in the life of any Cambrian creature. To grow, the organism had to secrete enzymes to dissolve the inner layers of its own armor, swell its body with seawater to crack the remaining shell, and emerge into the cold brine as a soft, defenseless ghost. In these moments, the high-viscosity water felt like lead, and the chemical signatures of the molting fluid acted as a beacon for every scavenger in the dark. The nervous system was pushed to its limits during this transition, coordinating a full-body escape from its own skeleton while maintaining a state of hypervigilance. The legacy of chitin is a reflection on the duality of protection and imprisonment. It provided the structure that allowed for the development of jointed limbs, complex mouthparts, and sophisticated eyes, yet it also defined the limits of the arthropod form. As you lie in the stillness of your own room, your skeleton hidden beneath layers of soft tissue, you are the inverse of the Cambrian masters. They wore their strength on the outside, exposing their vulnerability only in the fleeting moments of growth. We are built on a different chemical promise, yet we share the same fundamental drive to shield our internal spark from the indifferent pressures of the world. The chemistry of chitin was the first great wall built by life, a testament to the fact that in the deep time of the abyss, survival is often a matter of how well you can harden your heart against the dark. In the lightless depths of the Cambrian, where the skeletal innovations of chitin and calcite were still in their infancy, another form of biological architecture reigned supreme, the hydrostatic skeleton. This is the engineering of the soft and the pressurized, a world where life is held together not by bone, but by the strategic manipulation of incompressible fluids. To imagine the movements of the great Cambrian worms and the soft-bodied wanderers like Hallucigenia is to visualize a slow-motion ballet of internal hydraulics. Here, the environment is a constant weight, a relentless crushing force that these organisms did not merely resist but harnessed. By sequestering seawater within their muscular cavities, they turned the very pressure of the abyss into a structural asset, creating a rigid internal pillar against which their muscles could pull. The biological mechanics of this movement are defined by a rhythmic, undulating peristalsis. Within the body wall of these creatures lies a dual layer of musculature, circular muscles that ring the body like hoops, and longitudinal muscles that run its length. When the circular muscles contract, the internal fluid pressure is forced forward, elongating the body into a narrow, searching probe. When the longitudinal muscles take over, the body shortens and widens, anchoring itself against the silt. Peer-reviewed research from 2025 has highlighted the terrifying efficiency of this anchor and pull locomotion in the Cambrian's thick anoxic muds. It allowed these creatures to tunnel through the sediment with a silent hydraulic power, their bodies pulsing like a beating heart as they navigated the dark. This was a movement of pure pressure, a testament to the fact that in the deep, even the softest flesh can become as formidable as a piston. However, the hydrostatic life was one of extreme metabolic vulnerability. Maintaining this internal pressure required a constant, delicate balance of ions and fluids, a process managed by a decentralized nervous system that was hypersensitive to the chemistry of the surrounding brine. Any breach in the skin puncture from a biwaxia spine or the shearing strike of an Anomalocaris appendage resulted in an immediate and catastrophic loss of structural integrity. Without its internal pressure, the creature would collapse into a shapeless mass of tissue, unable to move, breed, or defend itself. The seafloor was littered with these deflated ghosts, the remains of those whose hydraulic seals had failed in the heat of the hunt. It was a life lived on the edge of a pinprick, with the very fluid that gave you form could also be your undoing. Reflecting on these hydrostatic horrors brings us to a humbling realization about the nature of resilience. We often equate strength with hardness, with the permanence of bone and the rigidity of steel. Yet the most enduring lineages of the Cambrian were those that mastered the fluid and the flexible. They remind us that there is a profound power in yielding to the pressure of one's environment rather than fighting it. As you drift towards sleep, your own body experiences a subtle shift in its internal pressures, a softening of the muscles as the day's tensions dissolve. We are, in our own way, creatures of fluid and pulse, distant echoes of the soft-bodied pioneers who first learned to turn the crushing weight of the world into a means of moving through the dark. In the deep time of the Cambrian, the end of a life was never the end of a story. It was the commencement of a complex silent chemical redistribution known as the scavenger's banquet. When a titan like Anomalocaris or a massive trilobite succumbed to age, injury, or the shifting chemistry of the brine, its descent through the water column was a slow-motion fall of biological wealth. This was the era's version of marine snow, but instead of the fine dust of modern oceans, it was a rain of chitin, protein, and mineralized shell. As the carcass settled into the anoxic silt of the seafloor, it created a localized oasis of energy in a world of scarcity, a beacon for the specialized cleaners of the abyss who lived in the shadows of the grass hunters. The biological mechanics of the Cambrian scavenger were defined by sensory acuity rather than brute strength. Creatures like the priapulid worms, the penis worms of the Burgess Shale, would emerge from their vertical burrows, guided by the chemosensory detection of decaying tissue. Their nervous systems were tuned to the faint sulfurous plumes of decomposition, a chemical trail that acted as a map in the lightless deep. Peer-reviewed data from 2025 emphasizes the role of these scavengers in biochemical recycling. They possessed irreversible pharynges, armed with rows of curved teeth that could rasp away the softening flesh between the armored plates of a fallen giant. This process was not merely a feeding frenzy, it was a fundamental component of the carbon cycle, ensuring that the precious molecules of life were not lost to the sediment, but were instead reintegrated into the living web of the ocean. Beneath the larger scavengers, a microscopic world of bacteria and fungi worked in a silent, subterranean rhythm. These microbes were the ultimate arbiters of the banquet, breaking down the complex polymers of chitin and collagen that even the worms could not digest. This microbial activity often created a preservation halo around the carcass, shifting the local pH and triggering the rapid mineralization that would eventually turn these ancient remains into the exquisite fossils of the Burgess Shale. The environment of the banquet was one of profound stillness, interrupted only by the rhythmic hydraulic pulsing of the worms and the slow, inevitable dissolution of the body into the inorganic mud. It was a place where the distinction between life and the earth became blurred, a cold chemical transition that sustained the next generation of monsters. To contemplate the scavenger's banquet is to reflect on the beautiful, terrifying economy of nature. Nothing is wasted in the deep. Every snap of a jaw and every death in the dark is a contribution to the continuity of the whole. It reminds us that our own bodies are merely temporary vessels for atoms that have been cycled through 1 billion banquets before our time. As ye drift toward the stillness of sleep, you are participating in a quieter version of this recycling. The slow metabolic repair of your cells, a subtle humming of life that persists even in the absence of consciousness. We are the inheritors of an ancient efficiency, a reminder that in the long cold history of the Earth, every ending is a preparation for a new beginning in the shadows of the eternal dark. In the profound depths of the Cambrian, the surface of the seafloor was not merely a boundary, but a frontier. For eons, the life of the Proterozoic had been content to drift or glide atop the microbial mats. But as the nightmare intensified, the sediment itself became a sanctuary. This era marked the beginning of the agronomic revolution, a vertical expansion of life that transformed the stagnant, anoxic mud into a ventilated laboratory of evolution. To burrow was to escape the visual field of the radiodonts, to retreat into a world of tactile pressure and chemical gradients where the light could not follow. The environment within the sediment was a claustrophobic, high-pressure realm characterized by a steep decline in oxygen and a rising concentration of toxic hydrogen sulfide, requiring a radical set of biological adaptations to survive the descent. The mechanics of this subterranean life were driven by the invention of the hydraulic anchor. Creatures such as the early brachiopods and various worm-like Lophotrozoans developed specialized fleshy stalks or pedicles that could be engorged with fluid to lock them into the silt. Peer-reviewed studies from 2025 have mapped the trace fossils of this era, the Trectignus pedum revealing a complex architecture of branching tunnels that suggest a sophisticated, systematic exploration of the substrate. This bioturbation was a planetary-scale engineering project. By churning the mud, these burrowers acted as biological pumps, forcing oxygen-rich water into the deeper, suffocating layers. This altered the very chemistry of the Earth's crust, breaking up the ancient microbial mats and allowing for a new, three-dimensional complexity that would eventually support the roots of the first land plants millions of years later. Living in the anoxic dark required a metabolic revolution to function in an environment where oxygen was a luxury. These burrowers developed high-affinity respiratory pigments, primitive hemoglobins, and hemerythrins capable of stripping every available molecule of oxygen from the surrounding brine. Their nervous systems were stripped of the visual complexity of the surface, focusing instead on hypersensitive mechanoreceptors and chemoreceptors that could detect the vibration of a predator's footfall on the sand above, or the chemical signature of a nutrient-rich pocket of decay. It was a life of slow, calculated movements, where the energy cost of every millimeter tunneled was weighed against the survival benefit of the dark. The sediment was a cold, thick embrace. A world where the only sound was the low-frequency thrum of the tides transmitted through the grains of silicate. The descent into the anoxic dark is a reflection on the length to which life will go to find a foothold in an indifferent universe. It reminds us that often the path to survival is not upward toward the light, but downward into the difficult, the hidden, and the pressurized. As you sink into the weighted comfort of your bed, you are experiencing a version of this ancient retreat withdrawal from the sensory deluge of the waking world into a private, darkened space of recovery. We are the descendants of those who learned to breathe in the places where others suffocated, who found safety in the crushing weight of the earth. The silence of the Cambrian burrow is the silence of persistence, a reminder that even in the most hostile shadows, life finds a way to pulse, to breathe, and to endure. The stillness of the Cambrian was occasionally shattered by events of such sudden subterranean violence that they froze time itself. In the area we now know as the Canadian Rockies, the continental shelf of 508 million years ago was a precarious ledge of unstable silt and clay looming over a deep anoxic basin. Without the stabilizing roots of plants or the complex reef systems of later eras, these sediment banks were prone to catastrophic failure. A subtle tectonic tremor or a particularly heavy tidal surge was all it took to trigger a turbidity, current, and mudslide of eternity. This was not a slow drift of dust, but a high-velocity, underwater avalanche of fine-grained slurry that raced down the slope, entombing everything in its path with the cold, suffocating efficiency of a geological trap. The physics of these mudslides were the primary architect of the Burgess Shale. As the wall of silt descended, it created a localized vacuum, pulling the inhabitants of the seafloor, the Anomalocaris, the hallucigenia, the fragile Pikaia, into a dense, turbulent cloud. Within seconds, the high-viscosity mud reached the bottom of the basin, an environment where the absence of oxygen and the lack of scavenging organisms halted the usual processes of decay. The pressure of the overlying sediment immediately began to flatten the organisms, pressing them into thin, carbonaceous films. Peer-reviewed data from 2025 and 2026 indicates that the specific clay chemistry of these slides acted as a biological fixative, inhibiting the enzymes that normally dissolve soft tissue and allowing for the preservation of brains, guts, and even individual muscle fibers. To be caught in such an event was to be rendered immortal in a heartbeat. The nervous systems of these creatures, in the midst of their final frantic pulses of escape, were suddenly encased in a mineralized grip that would hold for 500 million years. The sensory world, the vibration of the water, the chemical scent of fear, the visual grid of the compound eye was extinguished and replaced by the absolute unchanging silence of the stone. This was Lagerstadt preservation, a rare window into the soft-bodied reality of the deep that the standard rock record usually deletes. It is a haunting thought that the very catastrophe that ended these lives is the only reason we are now permitted to witness them. Reflecting on the mudslide of eternity brings us to the edge of the sublime, the realization that our understanding of history is entirely dependent on these accidental moments of preservation. We are looking at a snapshot of a nightmare, a single frame of a film that has been running for eons. As you settle into the stillness of your own room, imagine the weight of those 500 million years pressing down, not as a burden, but as a silent protective layer. We are all, in a sense, drifting toward our own place in the record, hoping that something of our essence survives the inevitable slide into the dark. The Burgess Shale is a reminder that even in the face of total annihilation, a ghostly imprint of the light remains, waiting in the silence to be found. The preservation of a creature in the Burgess Shale is not merely a matter of burial, but a complex chemical metamorphosis known as taphonomy. When the mudslide of the Cambrian finally settled, it created a tomb where the usual rules of biology were suspended. In the deep, anoxic stillness of the basin, the soft tissues of the nightmare, the undulating lobes of Anomalocaris, the delicate tentacles of hallucigenia, and the microscopic nerves of Pikaia began a slow transition from flesh to mineral. This was the birth of ghostly limbs, where the volatile carbon of a living body was replaced by stable aluminosilicates, creating a high-definition map of a life that ended 500 million years ago. To look upon these fossils is to see the phantom of a nervous system etched in a shimmering silver-grey film. The biological mechanics of this preservation are a masterpiece of geochemistry. As the pressure of the overlying sediment increased, the fluids were squeezed out of the entombed organisms, leaving behind a flattened, two-dimensional carbonaceous compression. Peer-reviewed studies from 2025 have utilized scanning electron microscopy to reveal that the decay was halted by the rapid precipitation of clay minerals onto the surface of the decaying tissues. This clay-organic interaction acted like a microscopic shroud, protecting the fine structures of the brain and the digestive tract from dissolution. In many specimens, the iridescent sheen of the original chitinous armor is still visible, a structural color that has survived the heat and pressure of tectonic shifts, a spectral reminder of the vibrant alien world that once thrived in the brine. The sensory detail preserved in these fossils is staggering. We can see the individual lenses of compound eyes, the fine hairs on the legs of trilobites, and the contents of a predator's last meal still resting within its gut. The nervous systems, once thought to be too fragile for the fossil record, are now being mapped with terrifying precision. We can trace the neural pathways from the five eyes of Opabinia to its centralized ganglia, witnessing the very circuitry of a 500 million year old fear. This is the taphonomy of the soul, the physical residue of consciousness and instinct, captured in a moment of geological stasis. It is a world of silver and shadow, where the complexity of life is rendered in the cold, unblinking permanence of stone. Reflecting on these ghostly limbs brings us to a profound realization about the nature of memory. We often think of the past as something that vanishes, a series of moments that dissolve into the void, yet the earth remembers. In the dark, pressurized layers of the shale, the Cambrian nightmare is still unfolding. a silent performance that requires only a witness to bring it back to life. As you drift toward the dreamless dark of sleep, your own memories are being encoded and stored. A biological taphonomy of the mind. We are all leaving behind a record, whether in the synapses of our brains or the minerals of the earth, a testament to the fact that we were her and that we witnessed the light before the silence of the eons reclaimed us. The act of reclaiming the Cambrian from the silence of the stone is a process fraught with intellectual vertigo, a journey of reconstructing the impossible. For over a century, the fragments preserved in the shale acted as a Rorschach test for the human mind, challenging our very definitions of symmetry and lineage. To look at the first fossils of Anomalocaris was to see a fragmented puzzle. The circular mouth was initially classified as a jellyfish, and the spiked feeding appendages were thought to be the tails of shrimp. This was a period of paleontological disorientation, where the sheer otherness of the Cambrian monsters exceeded the imaginative capacity of the scientists who found them. The environment of the laboratory became as pressurized as the abyss itself, as researchers struggled to fit these alien architectures into a tree of life that seemed to have no room for them. The biological mechanics of reconstruction have been transformed by the arrival of 2025 and 22.6 digital taphonomy. We no longer rely solely on the naked eye or the needle. Instead, we use micro-CT scanning and synchrotron radiation to peer through the layers of shale without disturbing the carbonaceous film. This allows us to reconstruct the three-dimensional musculature of Opabinia, or the internal neural architecture of a trilobite in high-fidelity virtual space. We can now simulate the fluid dynamics of a radiodont swimming lobes, calculating the precise newtons of force generated by a half-billion-year-old contraction. This is the science of digital resurrection, where the cold mathematics of physics are used to breathe motion back into the ghosts of the deep. It is a process that reveals the rigorous functional logic behind even the most surreal Cambrian forms. However, the more we reconstruct, the more we are forced to confront the great unconformity of our own understanding. Many of these creatures are stem group organisms, experimental lineages that lead to no living descendants. They represent a biological road not taken, a series of failed masterpieces that suggest our own existence was never a certainty. The nervous systems we map, while sophisticated, operate on principles that sometimes defy modern analogues. The reconstruction of the impossible is not just about the bones and the muscles. It is about reconstructing the alien consciousness of the deep, trying to understand how a world without color, without sound, and without precedent was perceived by eyes made of crystal. This process of reconstruction is a reflection on the limits of human knowledge. We are attempting to build a bridge across an ocean of time that is too vast to truly comprehend. As you lie in the quiet of your own space, realize that you are the culmination of all the paths that did not end in the shale. We are the lucky descendants of the survivors, yet we carry the echoes of the impossible within our own DNA. The reconstruction of the Cambrian nightmare is, in the end, an act of humility, a recognition that the world has been many different, terrifying, and beautiful things long before we arrive to name them. We are merely the latest dreamers in a world that has known 1,000 different kinds of sleep. In the deep architecture of the Earth's crust, there exists a silence more profound than the absence of sound. It is the absence of time itself. This is the great unconformity, a staggering chronological void where hundreds of millions of years of geological memory have been erased from the rock record. As we descend through the strata of the Cambrian, we eventually strike a jagged, horizontal line A boundary where the fossil-rich shales sit directly atop ancient crystalline basement rocks that are billions of years old. Between them lies a ghost, a missing interval of time that represents a significant portion of our planet's history. The environment of this boundary is one of haunting emptiness, a place where the narrative of life was scrubbed clean by the relentless forces of erosion and tectonic upheaval before the Cambrian nightmare even began. The scientific mechanics of this gap are a subject of intense peer-reviewed debate in 2025 and 2026. One leading hypothesis suggests that the unconformity was carved by the snowball Earth glaciation's massive, global ice sheets that acted like planetary-scale sandpaper, grinding away kilometers of crust and dumping the pulverized remains into the sea. This global scouring event may have been the very thing that primed the ocean for the Cambrian explosion. As the ice melted, it released a staggering deluge of minerals, calcium, potassium, and phosphorus into the water column. This sudden chemical enrichment provided the raw materials for the shells, eyes, and skeletons we had explored. The Great Unconformity is not merely a hole in time, it is the chemical womb from which the monsters of the deep were born, a period of destruction that laid the foundation for the most creative era in biological history. Contemplating this void requires a surrender to the scale of deep time. To a human mind, 1,000 years is an eternity, yet here we face a gap of 500 million years that has simply vanished. It is as if 1,000 volumes of a history book were burned, leaving only the first page and the final chapter. The nervous systems we have studied, the complex eyes of the trilobite and the predatory drive of the radiodont, emerged into a world that had already endured untold eons of silent, undocumented struggle. The Great Unconformity reminds us that our record of the past is fragile and incomplete, a series of islands in a vast dark sea of forgetting. We are seeing only the survivors of a much older, deeper mystery. As you drift closer to the edge of consciousness, consider the great unconformity of your own memory, the vast, silent stretches of time that pass while you sleep, unrecorded and unremembered. We exist in the gaps between the moments we can recall, held together by a thin thread of continuity that defies the void. The Earth's missing centuries are a reflection of our own transience, a reminder that much of the universe's story happens in the dark, away from the witness of an eye. The Cambrian nightmare was a brief, brilliant flash of light in a history dominated by silence. As the weight of the eons presses down, we find peace in the realization that even in the absence of a record, the journey continues, unfolding in the quiet, unmapped depths of the eternal dark. As the Cambrian progressed, the era of biological experimentation reached a terrifying and monumental climax. The environment of the late Cambrian Sea was no longer the tentative, mineral-sparse womb of the early years, but a high-energy, high-competition theater of giants. The oxygen pulse had stabilized at a higher baseline, allowing life to push the physical limits of the arthropod blueprint. In the darkening depths, the scale of the nightmare expanded. Trilobites, once the size of coins, evolved into massive armored behemoths like Isotethus rex, some reaching lengths of over 70 centimeters. These were the tanks of the seafloor, shifting the tectonic sands with a weight that would have crushed their ancestors. The pressure of the water was now matched by the internal pressure of massive muscle blocks and the thickest calcite plating the world had ever seen. The biological mechanics of these giants were a marvel of late-stage Cambrian engineering. To support such immense carapaces, the molting process became a planetary event for the individual, a high-stakes geochemical drama that required the animal to sequester vast amounts of calcium carbonate. Peer-reviewed data from 2025 suggests that these large trilobites developed specialized respiratory structures, highly branched gill filaments to satisfy the metabolic demands of their massive bodies. Their nervous systems had to expand proportionally, managing a sprawling network of sensory hairs and mechanoreceptors that covered their armor like a field of wheat. The late Cambrian was an age of megabenthos, where the seafloor was dominated by heavy, slow-moving shadows that lived in a state of constant, rhythmic consumption. But the giants were not limited to the seafloor. In the open water, the radiodonts had also scaled their ambitions. Giant filter feeders and apex predators patrolled the currents, their undulating lateral lobes creating low-frequency vibrations that could be felt for miles through the high-viscosity brine. This increase in body size across all niches led to a deepening of the trophic pyramid, where the energy requirements of the top-tier monsters forced a total restructuring of the marine food web. The sea was no longer a collection of individual actors, but a massive, interconnected machine of energy transfer, where the death of a single giant could sustain an entire ecosystem of scavengers and microbes for months. It was a world of abundance, yet it carried the seeds of its own instability, a biological overextension that was reaching its breaking point. Reflecting on the giants of the late Cambrian brings us to a meditation on the cost of greatness. In the history of life, size is often a precursor to extinction, a commitment to a specific environment that becomes a trap when the world begins to change. These massive armored masters believed their dominion was eternal, yet they were held captive by the very oxygen and minerals that had fueled their growth. As you drift toward the deep silence of sleep, your own body feels heavy, anchored by the weight of the day and the gravity of the earth. We are all subject to the limits of our form, ephemeral giants in our own brief slice of time. The late Cambrian was a magnificent terminal crescendo, a reminder that even the most formidable armor cannot protect against the slow, inevitable cooling of the era. The terminal phase of the Cambrian was not marked by a sudden fiery cataclysm, but by a slow, suffocating cooling, a silent withdrawal of the life-giving warmth that had fueled the nightmare for 50 million years. As the great Ordovician biodiversification event loomed on the horizon, the planet's geochemical heart began to falter. The environment of the late Cambrian was gripped by a series of biomere extinctions, localized pulses of death that rippled through the global ocean. The oxygen pulse, once a steady drumbeat of evolution, became erratic. Cold, nutrient-poor waters from the abyssal plains began to upwell, flooding the shallow, sun-drenched shells with anoxic brine. For the giants of the era, the masters of chitin and calcite, the world was becoming a tomb of their own design. The biological mechanics of this first great extinction were centered on metabolic failure. The high-performance organisms, the radiodonts and the massive trilobites, were slaves to their oxygen-rich environments. As the levels of dissolved oxygen plummeted, their complex respiratory systems could no longer sustain the massive muscle blocks required for movement. Peer-reviewed data from 2025 and 2026 suggests that a shift in carbon isotopes at the end of the Cambrian indicates a massive collapse of the primary producers, the microbial mats and algae that formed a base of the food web. Without the energy of the sun being efficiently converted into biomass, the trophic pyramid crumbled from the bottom up. The predators, once the kings of the abyss, were the first to starve, their specialized maws and complex eyes useless in a sea devoid of prey. In the darkness, the survivors were the generalists, the small, unarmored and low metabolic creatures that had lived in the shadows of the giants. Pikaia's descendants, the early conodonts and jawless fish, found refuge in the deeper, more stable currents, their flexible internal scaffolds allowing them to endure conditions that shattered the rigid arthropods. The environment was undergoing a taxonomic winnowing, a brutal selection process that favored efficiency over armor. The seafloor, once a crowded theater of alien forms, became a desolate landscape of empty carapaces and dissolving shells. The silence of the deep-time ocean returned, but it was a different kind of silence, not the silence of a beginning, but the heavy, expectant silence of an ending. Contemplating the first great extinction is a reminder of the fragility of even the most dominant civilizations. The Cambrian nightmare was a masterpiece of biological engineering, yet it was erased by a few degrees of temperature change and a shift in the chemistry of the brine. It forces us to reflect on the indifferent nature of the planet we inhabit, a world that gives life with one hand and reclaims it with the other. As you drift into the quietude of sleep, you are experiencing a transition of your own cooling of the senses, a slowing of the metabolic fire. We are all passengers on a world that is constantly reinventing itself. A reminder that the only permanence in the history of the Earth is the steady, rhythmic pulse of the eons, moving through the dark toward a dawn we may never see. As the Cambrian sun set on an ocean of fallen giants, the shadow of the Ordovician began to lengthen across the seafloor. This was not a sudden erasure of the nightmare, but a slow, ghostly transformation where the surreal gave way to the recognizable. The environment was shifting from a world of experimental disparate forms into an era of integrated reef-building complexity. The great supercontinent of Gondwana continued its stately tectonic drift, altering the global currents and creating vast, shallow seas that were cooler and more stable than the volatile cradles of the early Cambrian. In this transition, the nightmare, organisms, the five-eyed ghosts, and the circular-mouthed titans began to flicker out of existence, replaced by the early cephalopods and the first true corals, marking the arrival of a new, more ordered hierarchy. The biological mechanics of this transition were defined by the Ordovician radiation. While the Cambrian was about the invention of body plans, the Ordovician was about the filling of niches. The descendants of Pikaia were no longer mere slivers of flesh. They had evolved into the first jawless fish, their bodies encased in bony plates, their nervous systems developing the first true vertebrate brains. The trilobites that survived the extinction were the specialist creatures that could roll into impenetrable balls or burrow deep into the nutrient-rich sediments. Peer-reviewed data from 2025 highlights the rise of the nautiloids, the first cephalopods, whose gas-filled shells allowed them to master buoyancy. These were the new masters of the water column, utilizing jet propulsion and tentacled intelligence to outmaneuver the last, lingering radiodonts. The chemistry of the ocean was also maturing. The calcite seas of the Cambrian, rich in the minerals that built the first eyes and shells, were being moderated by the emergence of massive filter-feeding communities. Brachiopods and bryozoans began to carpet the seafloor in densities previously unseen, acting as living filters that clarified the water and stabilized the sediment. This ecological stabilization reduced the frequency of the catastrophic mudslides that had created the Burgess Shale, making the preservation of soft tissue increasingly rare. The world was becoming modernized, a process where the wild, chaotic plasticity of life was being funneled into more efficient, sustainable lineages. The nightmare was being refined, its sharpest, most alien edges sanded down by the relentless pressure of competition. Contemplating the shadow of the Ordovician is a reflection on the nature of progress and loss. Every new era is built upon the ruins of the old, a cycle of creative destruction that has no end and no ultimate goal. The creatures of the Cambrian did not fail. They simply reached the end of their biological tether in a world that refused to stop changing. We are the inheritors of this transition, carrying the echoes of both the nightmare and the order within our own cells. As you drift toward the deep, silent core of sleep, you are moving through the shadows of your own personal history, leaving behind the chaos of the day for the structured peace of the night. The transition from the Cambrian to the Ordovician is a reminder that even the most terrifying dreams eventually dissolve into the morning of a new world. In the wake of the great extinctions, the ocean entered a period of profound geological meditation. The once teeming arenas of the Burgess Shale and the Chengjiang formations were gradually enveloped in a quietude that would last for hundreds of millions of years. The environment was no longer a theatre of active struggle, but a vast cold archive where the remains of the Cambrian nightmare were curated by the Earth itself. Above, the waves continued their rhythmic tidal pulse, and the moon, still closer to the planet than in our modern age, pulled the sea in great sweeping cycles that felt like the breathing of a titan. But below the sediment-water interface, time had effectively stopped. The silence of the sediments is a silence of weight and mineralization, a slow-motion burial where the frantic energy of the hunt was replaced by the cold, unfeeling pressure of the lithosphere. The biological mechanics of this silence were driven by the slow chemical transition of the ocean floor from a soft microbial mat to a structured, layered history. As the fine silts and volcanic ashes settled, they exerted a vertical force that flattened the carapaces of the fallen, turning three-dimensional life into two-dimensional carbonaceous ghosts. Peer-reviewed data from 2025 emphasizes the role of the Great Unconformity in this process, the way gaps in the rock record act as silences between the notes of a symphony. Within these layers, the chemistry of the pore water changed, becoming enriched with silicates and carbonates that would eventually turn the soft mud into hard shale. This was the Earth's own memory encoding process, a physical storage of the information of life within the lattice of the stone. To understand the silence of the sediments is to understand the vastness of the intervals between the flashes of evolution. We focus on the explosion of the Cambrian, but the long periods of stratigraphic quiet that follow are equally significant. They represent the stability required for the Earth to process its own changes, a period of digestion where the innovations of the previous era were integrated into the crust. The nervous systems of the trilobites and the complex mores of the radiodonts were now part of the geochemical cycle, their atoms redistributed into the mineral veins of the mountains. The sea was a reservoir of potential, waiting for the next pulse of tectonic energy to stir the shadows and begin the nightmare anew. It was a world of slow, deep time cooling, where the heat of the planet's birth was slowly bleeding out into the void. As you drift toward the final heavy stillness of sleep, consider the silence of the sediments as a metaphor for the subconscious mind. Beneath the frantic activity of the waking day lies a vast, quiet archive of everything you have seen and felt, being slowly encoded into the structure of your memory. We are built on layers of history that we no longer perceive, held together by a continuity that survives the darkness of every night. The Cambrian fossils are a reminder that nothing is truly lost. It is simply waiting in the silence to be remembered. The weight of the world is not a burden, but a protective layer, a silent embrace that holds the spark of life until it is time to wake. In the ancient world of the Cambrian, the passage of time was marked not by the rising sun, but by the relentless hypnotic pull of the moon. This was a moon that existed in terrifying proximity to the Earth, appearing 30% larger in the sky than it does today and exerting a gravitational force that churned the oceans with a violent, rhythmic intensity. The environment of the deep was dictated by this orbital dance, a world where the sea level shifted hundreds of feet in a matter of hours, creating a rhythmic pulse that dictated the biology of every creature in the abyss. The tides were the heartbeat of the nightmare, a massive global circulation of energy and oxygen that forced the water through the gills of the trilobites and the filtering spines of the radiodonts with a metronomic persistence. The biological mechanics of this tidal rhythm are encoded in the very structure of Cambrian life. Peer-reviewed data from 2025 and 2026, derived from the study of daily growth rings in fossilized shells, confirms that a Cambrian year lasted 420 days, with each day consisting of only 21 hours. This faster rotation, combined with the lunar pull, created a high-frequency environment that shaped the nervous systems of the early predators. The circadian rhythm of a herdia, or a Wywaxia, was a tighter, more urgent cycle than our own, a life lived in a world of rapid pressure changes and shifting light. The tides acted as a biological pump, flushing nutrients from the continental shelves into the deep basins, ensuring that the scavengers in the anoxic dark received a predictable, rhythmic delivery of organic snow. To the inhabitants of the deep, the pulse of the tides was the only constant in a world of predatory chaos. The rise and fall of the water column altered the hydrostatic pressure against their bodies, a subtle heavy vibration that could be felt through the sensory hairs of the arthropod shell or the delicate membranes of the caudate. This was the first music of the world, a low-frequency thrumming of the liquid mass of the ocean, moving in response to a celestial body. The nervous systems of these creatures were tuned to this frequency, utilizing the pressure changes to orient themselves in the lightless void. It was a world governed by the physics of the solar system, a reminder that the nightmare of the deep was not a closed system, but a dance choreographed by the stars and the gravity of the void. As you drift toward the final stages of sleep, your own body begins to mirror this ancient rhythmic pulse. Your breathing slows, your heart rate settles into a steady metrical beat, and the fluids of your brain begin a slow, nocturnal wash that clears away the debris of the day. We are still governed by these internal tides, a biological echo of the moon's ancient pull on the Cambrian Sea. The rhythm of the world is a source of profound peace, a realization that we are part of a much larger celestial motion that transcends the individual. The tides will continue to rise and fall long after we have joined the silence of the sediments, a rhythmic promise of continuity in a universe of shadow and light. In the vast stretching expanse of 500 million years, the concept of the individual begins to fray and eventually dissolve into the cold mathematics of deep time. To look upon the Cambrian is to confront the terrifying brevity of a human life, a flicker so faint it barely registers against the enduring silence of the shale. The environment of the abyss teaches us that the self is a temporary arrangement of atoms, a fleeting consensus of carbon and oxygen that has been borrowed from the earth and must inevitably be returned. In the deep, the distinction between the predator and the prey, the monster in the mud, is erased by the slow chemical transition of the eons. We are not separate from this nightmare. We are its distant, dreaming fragments, a way for the ancient sea to eventually look back upon itself. The biological mechanics of this dissolution are found in the relentless recycling of the elements. The phosphorus that once formed the rigid spines of a hallucigenia may now be the very mineral that structures your own bones. The nitrogen that powered the nervous system of an Anomalocaris now facilitates the firing of your own synapses as you drift towards sleep. Peer-reviewed data from 2025 and 2026 on biogeochemical cycling reveals that the Earth is a closed system of profound efficiency. There is no new life, only the constant rhythmic reconfiguring of the old. The self is merely a brief pattern in the flow of energy, a localized whirlpool in a global ocean of atoms that has been churning since the cooling of the crust. To accept this is to lose the fear of the dark, for the dark is simply the state of being reunited with the whole. The nervous system, with its frantic desire for continuity and its desperate map of me, is perhaps the greatest illusion of the evolutionary process. In the Cambrian, the first brains were forged to navigate a world of immediate physical threat, creating a sense of here and now to ensure survival. But as the centuries turn into millennia and the millennia into epochs, the now becomes an infinitesimal point. The sense of an individual life with its specific fears, memories, and desires is a luxury of the waking mind that the deep time record does not recognize. In the silence of the sediments, there is no ego, only the structural integrity of the minerals and the slow, indifferent march of the tectonic plates. We are participating in a grand, anonymous tradition of existence, a lineage of ghosts that stretches back to the first twitch of a caudate tail. As you linger on the edge of the dreamless void, allow the boundaries of your identity to soften and fade. The weight of your body, the rhythm of your breath, and the thoughts that drift through your mind are all part of a much larger, ancient motion. You are shedding the heavy armor of the self and sinking into the collective memory of the planet. There is a profound relief in this dissolution, a surrender to the realization that you do not have to carry the world. You are the world. The Cambrian nightmare was not something that happened to others. It is the foundation of what you are. As the lights of consciousness dim, you are returning to the state of the eternal dark, not as a stranger, but as a traveler finally coming home to the silt and the stars. Deep beneath the churning tides and the chaotic struggles of the Cambrian Sea, the Earth itself was undergoing a slow thermal surrender. To understand the nightmare, one must understand the heat, the primordial energy left over from the planet's violent birth, still radiating upward from the iron core through the mantle. In the early Cambrian, the crust was a thinner, more volatile membrane than the one we stand upon today. The environment was characterized by a subterranean fever, where hydrothermal vents spewed concentrated minerals and superheated brine into the lightless abyss, creating localized nurseries for the most alien chemistries of life. But as the eons progressed, the planet continued its long, inexorable cooling, a process of planetary entropy that dictated the pace of evolution and the eventual hardening of the world. The biological mechanics of life were inextricably tied to this geothermal cooling. The cytacees of the era were fueled by the high-energy interactions between the cooling crust and the global ocean, a chemical exchange that provided the raw materials for the first great skeletons. Peer-reviewed research from 2025 has focused on the Earth's heat engine, suggesting that the slowing of tectonic plates as the crust thickened altered the frequency of volcanic outgassing. This, in turn, shifted the atmospheric composition and the temperature of the deep brine. For the inhabitants of the Cambrian, heat was a source of metabolic speed. As the waters cooled, the frantic pace of the explosion began to settle into the more measured, sustainable rhythms of the later Paleozoic. The planet was moving from its turbulent youth into a more structured, stoic maturity. The nervous systems of the deep-sea inhabitants were the first to feel this thermal shift. Temperature dictates the speed of chemical reactions, and as the ambient heat of the ocean floor dissipated, the speed of the hunt subtly changed. The cooling of the crust meant that the high-energy, high-viscosity world of the early Cambrian was slowly becoming a place of greater density and lower volatility. This was a planetary scale calming, a reduction of the thermal noise that had characterized the Hadean and Archean eons. The Earth was becoming a place where complexity could be sustained for longer periods, where the nightmare could develop into the sophisticated ecosystems of the reefs. The crust was no longer a shifting, molten skin, but a solid foundation upon which the history of life could be written in the permanence of stone. As you lie in the cooling stillness of your own room, you are witnessing a micro-scale version of this planetary surrender. The heat of your day, the friction of thought, the warmth of movement, slowly radiating away into the sheets, leaving you in a state of thermal equilibrium with the night. We are all passengers on a cooling star, riding a crust that is still, after billions of years, finding its final shape. There is a deep existential peace in this cooling, a realization that the fire of life is always balanced by the cold embrace of the void. The Cambrian was a moment of intense, radiant energy, a spark in the dark that has left us with the embers of our own existence. As the planet cools, and as your own senses dim, we are reminded that the ultimate fate of the world is not a fire, but a long, quiet sleep in the cradle of the eternal dark. In the modern world, we look to the horizon for the unknown, but the true frontier has always remained beneath us. The eternal abyss is the only place on our planet where the spirit of the Cambrian still breathes in the crushing pressure and the absolute absence of the sun. As we descend past the sunlit layers of the pelagic zone, we pass through a liquid veil into the Hadal deeps the trenches, where the water column exerts a weight of 8 tons per square inch. This is the closest analogue to the primordial world, a place where the rules of biology are still written in the language of the hydrostatic and the chemical. The environment here is indifferent to the passage of empires. a cold, stable sanctuary where the darkness is not an absence, but a presence of thick, velvet reality that has remained unchanged for 500 million years. The biological mechanics of the abyss are defined by a terrifying economy of energy. In this realm, the creatures that mirror the Cambrians' nightmares. The Xenophius and the giant amphipods possess nervous systems that operate in a state of hypervigilance. Without light, the sensory world is constructed through mechanoreception. Every vibration in the high-viscosity brine is a potential meal or a terminal threat. Peer-reviewed data from 2025 and 2026 explores the concept of abyssal gigantism, a phenomenon where the cold and the pressure allow for the growth of massive, slow metabolic organisms, echoing the titans of the late Cambrian. These are the ghosts of the past, utilizing the same protein structures and the same pressurized internal scaffolds that allowed Pikaia and Anomalocaris to navigate the first oceans. The abyss is a reservoir of ancient designs, a place where evolution has found a perfection that requires no further modification. To contemplate the eternal abyss is to understand that the Earth is a world of water, and we are merely the inhabitants of its dry, temporary edges. The vast majority of our planet exists in this lightless state, a silent, pressurized volume that dwarfs the thin sliver of the atmosphere we call home. The chemistry of the deep, the heavy minerals, the sulfurous vents, and the marine snow is the true baseline of terrestrial life. The nervous systems that first developed in the Cambrian to track shadows in the brine are the ancestors of the very mind you use to contemplate the stars. We are the outliers, the creatures who left the dark for the light, carrying the salt of the abyss in our blood and the memory of the pressure in our bones. As you drift toward the final heavy descent into sleep, imagine yourself sinking past the reach of the tides, past the cooling crust, into the heart of the eternal abyss. There is no fear in this depth, only the profound comfort of the unchanging. The weight of the world is a protective embrace, a stabilization of the self against the chaos of the surface. We are returning to the origin, to the place where time is measured in the slow accumulation of silt and the rhythmic pulse of the planetary heart. The abyss is the final sanctuary, a reminder that the darkness is not a void to be feared, but a cradle to be embraced. In the silence of the deep, the Cambrian nightmare and the human dream are one and the same, dissolved into the cold, beautiful indifference of the eternal dark. The journey through the nightmare of the Cambrian has reached its final, inevitable destination. We have traveled through the invention of the eye, the crushing power of the first jaws, and the ghostly mineralization of the Burgess shale, only to arrive at the shore of a much larger silence. The environment of this moment is one of absolute sensory surrender, a place where the chemical and electrical signals of the mind begin to slow and dissolve into the background radiation of the universe. To enter the dreamless dark is to move beyond the reach of the fossils and the stone into a state of existence that predates the first heartbeat in the primordial sea. Here, the weight of 500 million years is no longer a burden, but a warm, heavy blanket of time, pressing down with a gentle and familiar gravity. The biological mechanics of sleep are the final echo of the Cambrian's cooling, as the neurons in your brain transition from the frantic synchronization of the day into the slow wave oscillations of the night. Your body is performing an ancient metabolic ritual. The high viscosity world of the hunt is replaced by a state of fluid stillness. Peer-reviewed research from 2025 on the neurobiology of deep state recovery suggests that in these moments, the brain's glymphatic system opens its channels, flushing the day's debris in a rhythmic tidal wash that mirrors the pulse of the ancient moon. This is the ultimate biochemical recycling, a cleansing of the nervous system that has been practiced by every caudate lineage since Pikaia first navigated the silts of the abyss. You are sinking into a sanctuary that was perfected in the dark, long before the sun ever warmed the land. In the dreamless dark, the self has no form. There are no compound eyes to track the shadows, no compound eyes to maintain, and no predatory drive to satisfy. You have become the sediment. You have become the water. The distinction between your breath and the movement of the air, between your warmth and the stillness of the room, is an illusion that has finally collapsed. This is the peace of the great unconformity, the gap in the record where nothing is written and nothing is lost. It is the state of pure potential, the silent womb of the earth where life waits for the next oxygen pulse to begin its frantic dance. You are resting in the heart of the nightmare, and in doing so, you have found that the nightmare was only a different kind of beauty, seen through the eyes of the deep. The silence is now absolute. The rhythmic thrum of the tides has faded into a faint, distant hum, and the pressure of the eons has become a cradle of perfect stability. There is nothing left to observe, and nothing left to fear. As the last sparks of thought flicker and die, you are reunited with the eternal dark, the same dark that held the trilobites, the same dark that nurtured the first fragile nerves, and the same dark that will remain when the sun has finished its work. We are all children of the abyss, returning to the stillness of the stone. Sleep now, in the heavy, unblinking embrace of deep time. The journey is over, and the silence is complete.